From the previous video, we have seen how Apache Kafka at most once delivery works. In that video, we have seen how a message can be lost by crashing a targeted partition leader, that is broker, while a producer is producing to that broker. In this video, we will test how Apache Kafka handles at least once delivery, meaning messages will not be lost, but may be duplicated. We will intentionally crash a broker mid-delivery and verify what actually reaches the topic. We may also crash our consumer after it processes a message, but before committing the message. I'm also thinking I might leave this last part for the viewer to practice. First, let us think of an analogy to compare with Kafka at least once message delivery. Let us think of tax refund office sending you a letter at the beginning of the year after you have filled your tax refund. The delivery person comes to your house and you are not around. He may drop the letter or give it to your neighbor if you don't have a mailbox. So assuming you are not around, and let's say you have traveled, or maybe he gave the letter to your neighbor and you have not met or seen each other since. What if the tax refund office are expecting response from you? They may resend the same letter again after some time, and you might end up having duplicates later. So this is same as in Kafka producer retry. When a leader of a partition is offline or crash, the producer will get leader not available error, and it will try automatically, making sure it delivers the message. This retry could cause duplicates. And the reason is this. Let's say the broker already received the message and propagated it to one or more in sync replicas because we set acknowledgement to all. But then the broker crashes before acknowledging the message to the producer. Now, if a new leader is elected for the partition and the new leader happens to have received that message already, because the producer have not received acknowledgement from the crash broker, it will retry and send the same message again to the new leader. We will end up having duplicate message. This is what at least once delivery mean. The producer will act all and retry set to some value. Like in our case, I set it to maximum integer, will try its best to deliver the message as long as the retry count is not exhausted and there is no timeout error. We will see this practically in a moment. I want to thank you all for watching this video. Don't forget to like, subscribe, and share. First, we will start by checking and launching our Kafka cluster using Docker Compose. We are going to use the same Docker Compose file we did in at most once delivery video. This is the same file. As you can see, I have 3 controllers and then 3 brokers, and we are using kraft mode. Let me go ahead and just start the cluster. And as usual, I will start it in normal mode, not in daemon mode, because I want us to see some of the logs. So now our cluster is ready. All the nodes and everything is up and running. We will continue by cleaning up the transaction IDs topic and create a new one with 3 partitions, 3 replicas, and durability or minimum in sync replicas of 2. This is to have a very clean environment and to know that we don't have anything in our topic and we don't have to go and read thousands of messages. But first, let us see how many topics we have in our cluster so that we know what we are dealing with. Okay, we have 3 topics and 1 internal topic. And one of the things we are going to do is to delete the transaction IDs topic. Is the same ID we used before. Oh, sorry, I mistyped the name. Now I have deleted the topic. If I'm to go to list the topic again, you'll see it is not there. So the next thing we are going to do is also to create the topic again. And as you can see, we have replication factor of 3, partition 3, and minimum in sync replicas of 2. So we are recreating the same topic, and we will list again to see if our topic is there. So you can see now our topic is there and it is created. It is also a good practice to inspect internal topics. E.g., you can see above here we have consumer offset topic. If the minimum in sync replicas of this topic is too high and your broker crash, unless there are still enough brokers to meet that requirement, your whole cluster will be unstable until the crash broker is back. Possibly your producers will not be able to send messages during that time. For example, in our case, we only have 3 brokers. If the consumer offset topics minimum in sync replicas is set to 3 and one of the broker crash, until it is back, the cluster will stagnate and no producer will be able to send messages during that time. So for that reason, it is good to always check or verify what exactly is there. So we are checking, it's always having a lot of partitions. You can see we have 50 partitions in this topic. We have 3 replicas and then minimum in sync replicas of 2. So we are good to go. We want to target the leader partition 0 to crash or stop the broker while we are sending our message to that broker. This is to simulate broker failure. Let us check who is the leader of partition 0 by describing the topic we created. We can just describe the topic. As we can see, node 4 is the leader of partition 0 and we have 3 in sync replicas. And then if we go to our tab or if we go back to our Docker Compose, we can see that node 4 is actually broker 1. Let us just get one of our command ready, that is docker stop and the broker that we want to kill while we are sending the message. So let us go ahead and look at our Java app. You can see I have a simple controller here that just loop and send 10 messages. We are not here for Java course, so the code quality and everything is not an issue, or it's not something that we are here to look into. And another thing that we should look is the producer. You can see the producer I'm sending specifically to partition 0. And if we go to the producer config, some of the things I changed in respect to previous video at most once delivery is the acknowledgement. Here the acknowledgement is all, and also I have set retry to maximum int. With the acknowledgement of all, I am telling the Kafka broker that all in sync replicas, that is the minimum in sync replicas, in our case 2, must receive this message before you can acknowledge it. Also, I am setting the retry to maximum int. I'm telling my producer, as long as you are getting retriable errors, then keep trying again. An example of retriable errors is like leader not available exception. This is retriable error. So the producer will keep on trying as far as it's is getting this kind of error. There are some errors that the producer will not retry again, such as configuration errors. It will keep on trying here, and for that reason we are expecting, even if the broker is down, because the producer is trying, by the time our cluster will stabilize and elect a new leader for the partition we are sending message to, then the producer will succeed. In the case of consumer, we don't have much changes. I didn't change anything there. It is the same as in the previous video. So we will keep on. We are expecting just one record from a batch, and we have set the acknowledgement mode to manual. And if you go to also the listener, I have shown you this listener here. We are acknowledging manually. For your information, as I said, we are not here for Java course, so the sleeping here is just to simulate message processing. So they are not here for code quality or anything. This is not production code. It's just a code to test on the local machine. Our Java app is also okay. Let us go ahead and start the Java app. Now we can see our Java consumer, or the transaction ID consumer, is assigned partition 0, partition 1, and partition 2. That is great. So also Java is ready. One of the things we are going to do is that we are going to use Postman to send our message to the Java app. And as soon as we start sending messages, we will stop the broker that is the leader of partition 0. This is to simulate real crash during at least once delivery. As you remember, or if you could remember, our Docker command for stopping that node is ready. Let us go and send the messages. Click send. We go back here and we come and stop the broker. Now the broker has stopped. Our messages are all sent. If we go back to the cluster logs. So in order not to take too much of your time, we are just going down to the logs. You can see when the broker is shutting down, when it shuts down, or when the shutdown completed. But as you can see, actually our cluster have now stabilized and everything is ready to keep on consuming the messages again. Of course, Kafka will automatically re-elect a new leader for the affected partition. And now we will describe our topic again to see who is the new leader of partition 0. So if we go back to our terminal, we know that, like, if we check docker ps, we know that still the broker is down. And now we can go here, also check who is the new leader of our partition 0. Previously, we know that it is leader 4. What about now? You can see now node 5 is the new leader of partition 0. And as you can see, we only have 2 in sync replicas, that is node 5 and 6. This indicates that our cluster has stabilized and everything is back to normal. Now, let us verify if our messages have all made it to the topic, whether we have duplicate or not. Remember, with ask all, retries, maximum int, we are not expecting message loss. It is possible to have duplicate messages because of the producer retry. And for that reason, we could have duplicate messages, but we are not expecting message loss. So let us check, or let us consume the messages and see. We just sent 10 messages and let us see what happens there. And as you can see, we have T0, T1, 2, 3, 4, 5, 6, 7, 8, and 9. It seems like our cluster is stable and we don't have duplicate. We don't even lost any message. It is possible to have duplicate, but it is not must. So we are all good. Our messages are intact and our cluster is also stable. Another part of this test is the consumer side of the puzzle. I will leave this to you so that you can practice with it. Here is the test. Start a consumer and set the acknowledgement mode to manual and auto commit to false. That way you will commit processed messages manually. Simulate the consumer crash by stopping the consumer after processing a message, but before the consumer acknowledge or commit the message. Restart the consumer again to see how the consumer will reprocess the processed message again. This means even though you have one message in the broker, you should also have a way of detecting duplicate messages in your code if you don't want that to happen. That means if you don't want consumer to be processing messages or the same message twice. What did we learn from this? Still, we know that delivery guarantees depend on producer config. That is why we set ask to all and retry to some value, in our case max int. Also, at least once delivery means keep sending or retrying until the message is delivered, or retry exhausted, or we get timeout error. And because of the retry, there is possibility of having duplicate message. Because the arc is all, the broker will only acknowledge the received message after all the minimum in sync replicas receive the message. This is Kafka's at least once message delivery guarantee. See you in the next video exploring Kafka's exactly once message delivery guarantee.